Hi everyone. So let's continue where we left off. So we have the following problem. Let P be prime if 2P minus 1 is prime. Proves that P is prime. So this is really a structural result, as you'll see in the proof. So how structures vary with respect to each other is what I say about structural result. So we'll prove the contrapositive. So assume that P is composite. So that means that P is A times B. So therefore, you have 2AB minus 1. We want to prove that that's composite, but we can set x to be equal to 2 times A and n to be B. So then that becomes x to the n, because here that would be 2 to the A to the power of B minus 1, which is equal to x to the n minus 1, and that can be factored using the telescope series. So that would be x minus 1 multiplied by x to the n minus 1 plus 1. And so we can see that 2 to the AB minus 1 is also composite as well. And we are done. It's just like heuristically speaking, if P is prime, so then that means that you have, if P is, if 2 to the P minus 1 is prime, then you've generated an odd number that comes from powers of 2, and you subtracted 1 to that. So then that must mean that P is prime, because you end up going in the same direction as this proof. You get like this structural intuition. So yeah, that's the main idea. So what do I mean by same structural intuition? It's just like you'll have so 2P minus 1 would be an odd value, that this odd value, you have reached it by powers of 2, by powers of 2, where that number is prime. So that means you can never reach this P unless it is prime. So that's the intuition about it. Yeah, it comes from this, it comes from the algebra here. All right, I'll end the video here, and thank you guys, and I'll see you in the next video.